Today we're going to take a look at multiplying rational expressions. So multiplying rational expression works very closely with just multiplying fractions. Like if I had 3 over 5 times, let's say like 6 over 9, something like that. We would simplify 3 and 9. 3 goes into 3 once, 3 goes into 9 3 times. And I could even simplify the 6 and 3 now. So 3 goes into 3 once, 3 goes into 6 twice. 2 times 1 is 2, 5 times 1 is 5, done. Simplifying rational expressions, multiplying rational expressions works the same way. But we just have like factors of like binomials and trinomials, so we got to factor and get all those factors out. But let's look at this one, 2x over 5 times 15 over 16x squared. So what could I do here? Well, 2 and 16 can be simplified. 2 goes into 2 once, 2 goes into 16 8 times. And then 5 and 15, 5 goes into 5 once, 5 goes into 15 3 times. And then I could even simplify the x and x squared. X goes into x one time. X squared is just going to become x. Because when we have x over x squared, big exponent is 2, 2 minus 1 is 1. So we'd have 1 over x, so the x would be left on bottom. And then nothing else to be simplified. So on top, I'm just left with 3. And on bottom, I'm left with 8x. So 3 over 8x. So that's the main concept with multiplying rational expression. And there'll be a separate video for dividing rational expressions. But let's look at this first one. So x squared minus 1 over x plus 2 times x over x minus 1. So we want to factor everything. Wherever we could factor, let's factor. So x squared minus 1 is a difference of two squares. So just knowing you're factoring. So x minus 1 times x plus 1 over x plus 2 times x over x minus 1. Didn't factor anything else. That was the only factor. So what can simplify out? Well, I have the x minus 1s. Those are going to cancel out because those are the same factors, just like simplifying rational expressions. X minus 1 over x minus 1 is 1, so those cancel out. And then I cannot simplify anything else, so I'm just going to multiply everything together now. So I have on top x times x plus 1 over x plus 2. And no, you cannot cancel out those x's or anything like that, because remember, x is equal to a number, so that would be like x equal to 2, so it's 2 times 2 plus 1 over 2 plus 2. So that's all of those are just visualizations of an actual number. So then that would be our answer. So it's factoring and then looking for cancellations there. So number 2, 2x plus 4 over x squared minus 4x times x squared minus 2x over 2x squared minus 8. So a lot of factoring is going to happen. So go through each individual term and try to factor out GCFs. Then look to see, does that create a perfect or difference of two squares? Does it create some sort of trinomial? Like, what does that generate? So on the first top left here, 2x plus 4, I can factor out a 2. So let's take out 2. So I'm left with x plus 2. In the denominator of that term, I have x squared minus 4x. I could take out an x. So let's take out that x. So I have x minus 4. Top right, x squared minus 2x. I could take out an x from there. What am I left with? X minus 2. And then bottom right, 2x squared minus 8. I could take out a 2. And that leaves me with x squared minus 4. Not done, because now that has generated a difference of two squares. So I'm going to factor the difference of two squares. So I'm going to go over here. So 2 times x plus 2. So everything is going to stay because I can't factor anything else besides that. So I'm going to factor that term. So that's going to be x minus 2. And then a difference of two squares. So that's going to be 2 times x minus 2 times x plus 2. Cool. Now we have a lot of cancellations. This is the fun part. So we have x plus 2 over x plus 2. Boom. Bam. We have x minus 2 over x minus 2. Boom. Bam. We have x over x because I have an x here and an x here, a factor of x. So boom. Bam. And 2 and 2. Boom. Bam. Gone. Cool. Look at almost everything dropped out completely besides this one factor of x minus 4. So what do I have on top? I just have 1 over, and then I have an x minus 4 on the bottom. So 1 over x minus 4. Fun one there. Ooh, number 3. For some reason, when I've been typing up my no cheats here. When I convert it to a PDF, sometimes it's not catching everything. Like this plus 40, I had to actually write that in for some reason. Like I don't know what's going on. I got to figure it out. But some of my PDFs look a little weird. But I have a bunch of trinomials. So we have a lot of trinomial factoring that we need to do here. So first one, top left, x squared plus 7x plus 6. I want two numbers that multiply to 6, add up to 7. That's going to be 6 and 1. So x plus 6 times x plus 1. On the bottom, x squared minus 14x plus 45. So two numbers that multiply to 45, add up to negative 14. They both have to be negative because we want to multiply to a positive, add up to a negative. So that's going to be x minus 9, x minus 5. And then top right, x squared minus 13x plus 40. Two numbers that multiply to positive 40, add up to negative 13. That's kind of an interesting one. That's going to be 8 and 5. I was almost like, I got to think about this. That's going to be 8 and 5. So x minus 8, x minus 5. Because negative 8 times negative 5 is positive 40. Negative 8 plus negative 5 is negative 13. Okay, checks out. And then two numbers that multiply 36, add up to 12. That's going to be x plus 6 and x plus 6. 6 times 6 is 36. 6 plus 6 is 12. All right, so a bunch of factoring there. What can we simplify? X plus 6. I have an x plus 6 here. I have an x plus 6 here. So gone. It doesn't cancel out with both of them. I need another factor of x plus 6 in the numerator in order to cancel that out. What else? Is anything else? X plus 1? No. X minus 8? No. X minus 5? Those are going to cancel out. So I'm left with multiple terms here. So I'm going to rewrite this as x plus 1 times x minus 8 over, and then I have x minus 9 and x plus 6. And that's it. Nothing else can simplify. And you don't have to multiply it back out or anything. Just leave it like that, and then we're good to go. So the next video will then be on dividing rational expressions.